Hello everybody, welcome back to our virtual classroom and another lesson in our trades training video series. I'm Joe Carswell, your instructor, and in this lesson we're going to cover the table saw, a great power tool to do rip cuts. We're going to talk about what rip cuts are, all the parts of this saw, and how to make it work safely and effectively. So let's go ahead and get into it. We are really trying to grow this channel, and the best way for that to happen is for you, the viewer, to subscribe. Also, if you learned something from these videos, don't forget to click like. So thanks for your support. Let's get back into the lesson. So to get started, let's talk about a rip cut. A rip cut is made, if we're talking about wood, the rip cut will always follow the grain of the wood. If we're not talking about the wood grain, we're talking about the length of the board. So a rip cut will always travel in the longest length of the board. This tool is set up great for that. It can do a lot of things, a table saw, but mainly it does rip cuts. It can also do a cross cut, but we have a better tool for that. And in my opinion, a cross cut on this saw is not only an inconvenience, it also gets into some dangerous situations. And we'll go through how the saw works, and hopefully that'll make more sense to you. I know a lot of woodworkers or people in wood shops have very fancy table saws. This is a job site version. It is portable. I call it semi-stationary. You set it up on the job site typically once a day. You'll tear it down and carry it off with you. So this saw does not have the power or a lot of the size and potential that a workshop version would. So on a job site, this is typically used for these long cuts we call rip cuts. It's great for that, and a lot of the parts and pieces will lead us to why that is. Starting with the basic concept. So a table saw is a nice flat top. This is a milled flat surface. It should be flat, and it should be clear of any extra materials or anything. This is what our material is going to travel over, and that gets to this idea of what this saw does and how it works differently than other tools. So instead of all of our other tools that we're holding or putting in place and then putting our materials to them and holding the materials still, this is a different setup. We're taking the materials and then moving them through this saw. That's why this saw is so much different than all the other ones that we've done so far, why it creates safety issues, and why we have to think of it completely different. So we have the table, and out from the table is a blade. And this blade is fixed to a degree, but it's also adjustable. This blade will move up and down depending on which way we turn this knob. And there is no lock on that. Once you let go of it, it fixes that blade at a certain height. The height of the blade is very similar to our circular saw. We need to set that blade deeper or higher than the material that we're cutting. This blade also has an adjustment for the angle of it. So the angle can be adjusted anywhere. If you look at the gauge, you can set it all the way to 45 degrees, and that's relative to the table. It adjusts all the way from 45 to 90 degrees. That's relative to the table. At 90 degrees, this blade is perfectly vertical. This is a lock lever. So once we get the right angle, we can lock that down. It won't be moving when we're using it. So we understand we have a table surface and a blade that comes out of it that's adjustable. The next part to talk about is the fence. This is a very straight edge that is set here, and it's adjustable as well. I have a lock for that here. And when I release this lock, I can then move this fence closer or further away from this blade. It's very important that this is parallel to that blade. We'll get into that when we talk about setup. And then when we set it at the right width that we want, we can lock it down again. We have a lot of safety features on this saw, and a lot of them are located right where the blade is. We'll go over those in more detail later as we talk about the setup and how all that works. But my parts go like this. I have a riving knife that sits in the back of the blade. This is a fixed piece. You might hear it called a splitter. This part always has to be in place and will prevent a lot of kickback, and we'll talk about what that is. I have my kickback arresters, which are basically teeth that grab the board and prevent it from being thrown at us while we're working. And I also have a blade guard. This whole contraption here is to protect us or shield us from the blade while we're using this saw. It's not that much different than a movable blade guard on a circular saw, and these parts will move out of the way as we push the material through. The other safety feature on the saw would be a push stick, and this is nothing more than a simple stick to keep distance between our hands and the blade. This tool will, if it happens to come in contact with the blade, it's made of plastic, so it won't ruin the blade, and it's much better than your hand making contact with the blade. The power switch will always be located on the front of the table saw, and all table saws are a little different, but it's very important that power switch is accessible to you as the user. If you have an emergency, they're generally pretty big, like a large paddle switch, and that can be turned off in an emergency. If your hands aren't free or if they're injured, you could turn it off with an elbow or a knee. Also, there's a power cord, and I've never seen a table saw with a long power cord. They're usually very short. It's not often that you can plug this directly into an outlet. So what you need to do is to use an extension cord that is rated for the right amperage for the power tool being used. All of these tools have a plate on them that rate their amperage, and a 15 to 20 amp extension cord is usually enough to run most job site table saws. Now that we've been through all the parts and pieces of a table saw, we can take those parts and talk about how they work in the process of using this saw. So let's go over the fundamentals on how this saw works. Remember, we had a 2x4 and we want to make a rip cut in it, which is a cut along the length of this board. That material will pass through the saw from front of the saw to the back of the saw, and the blade is always spinning towards us. That is not a good combination for safety as the saw sits now. All of the safety stuff will help, but that blade is always trying to throw that material back at you. That can be a dangerous situation. We call that kickback. You're going to hear that term a lot when we talk about the table saw. So the saw is always trying to throw that material towards you. You're always holding it and pushing it through to get all the way through the cut. The other thing to think about is that the part of the material that you're trying to keep is between the fence edge and the blade. Anything that is over on this side becomes scrap. So all of this material becomes your accurate cut that you're trying to make. So say we need to cut this 2x4, make a rip cut in it exactly in two, or we want to cut it in half. There's a couple of main things that we need to do. That's going to be to set our blade height to clear this material, and we also need to set our fence to the right position so that the cut is in exactly the right place. Before we get any further, it's really important that we check the angle on our blade. We need to true the blade, and I'll show you how to do that. So we want a square cut in this lumber, or we want that blade to be perfectly vertical to this flat table surface. A great tool to check for that would be a speed square. The speed square will sit on the table and it should rest up perfectly against the blade edge. I've got this blade raised to the maximum height that it's allowed on this saw, so I get the most surface to check. As you can see, there's no extra gaps on the top or the bottom. That's telling me that my blade is perfectly square. Let's take a close look at what the blade looks like when it's not true. And I've loosened my bevel adjustment here. I'm tilting my blade, and as you see, the more out of vertical this blade is, or the less perpendicular to the table, the more of a gap I have at the bottom. The more true or square the two surfaces are together, I have no gap here. I would consider that a perfect setup for a vertical or square cut to my material. Then I would lock this lever. That's going to hold my angle in place. Now I can count on that square cut. Now that we've trued our blade and we have a perfectly vertical cut that we can make, we need to check the fence relative to the blade. This fence edge needs to be parallel to this blade edge. That will keep any binding from happening or any burning of the wood and prevent some of that kickback we talked about. So we can measure a distance from this fence to the inside of this blade on the front and the back of the blade. And if the measurement is the same, we know that we have a parallel condition here. We're not concerned about what the dimension is just that we have an equal dimension here as well as back here. That tells us it's parallel. So if I measure from here to here, it's telling me 3.5 inches to the inside of that tooth. So I would expect if this fence was parallel to this blade, I would also get 3.5 inches on the back here. That tells me I have a parallel condition. I can run my material through with no problem, and it will be an accurate cut. So now that we know that our blade is vertical to the table and that our fence is parallel to the blade, that means everything's true. Are we ready to make a cut yet? Not exactly. We're missing, as you notice, all of the safety equipment that was on the saw that kept us from getting into danger when we're using it. So let's go over those parts and what they will do for us specifically when we're making this cut. The first safety part on this table saw to talk about is the riving knife. You might hear it called a splitter, and that's because that's exactly what it does. It will split the wood once it passes beyond the blade and keep that wood from pinching back on itself. It will also keep any material from twisting inside of this blade, which is how you get kickback. That's another reason for kickback. So as this 2x4 is passing through, this is almost a stop for that material, and it's going to keep that wood straight. It will keep it tight against the fence and will help us in this cut. Without this riving knife, this material could climb up on top of this blade, and then as that blade is moving towards us, it can send that material directly into your face or your body at a really high speed, something like 100 to 200 miles an hour. Injury can occur from that, broken ribs, all kind of problems could even come into your face. So consider your riving knife it's a part that is non-negotiable, has to be there, and your other parts fasten to this, and we'll look at that now. Kickback is a big deal with the table saw, and we have more than one feature that will help prevent that. Next up is our kickback arrestor. This is a small feature, very small part, with sharp teeth on it. And we're going to fasten this onto our riving knife. And as that connects to the riving knife, it has springs on it. It's spring loaded. And as this material passes through this cut, those teeth will actually grab into that board. So this is a one-way feature on this saw. You can only pass material from front to back. There is no way that this material can come forward now. So even if the blade is trying to throw this material at you from the front, these features will hold that material in place and keep that from happening. The next safety part to mention is the blade guard. A lot of our power tools have blade guards. This one's not that much different. It should move out of the way as we use it. This piece also connects to our riving knife, and it just locks in. Now it's fixed, and it will move up and down as our material passes through this saw. And the purpose of our blade guard is very simple. All this does is prevent us from making contact with that blade that's spinning. And let me mention that you might see 100 table saws in your career, and you might only find one of them that still has the blade guard on it. It's very common for people to take these safety parts off and not use them. I've heard a lot of reasons why people don't use the blade guard. I don't understand this, and I can't find any good reason to take these safety parts off. And when we talk about actually how to make a cut, I hope I can convince you that these parts are necessary and they're not in your way when you're using this saw. So we've learned about how to true the blade, how to check for true parallel between the fence and the blade. We've figured out how to make a width setting between our fence and our blade, and we know how all the safety parts attach to the saw and their purpose and why they're so important. So let's put all of this together and make a cut, that original cut that I wanted to do that was splitting this board in half and making that rip cut. So let's go into the shop and get that done. I've got my table saw set up. Let's go ahead and make some of those rip cuts we talked about. I've got a 2x4 here, and I've got a couple of cameras. I'm talking to you here, and I've got my close-up camera back here. I'm going to try to stay out of your way when we're making these cuts, which means I'm on this side of the saw. Actually, that's really the best place to be when you're making these cuts. The wood that's going to be kicked back, if it happens will be this piece that's between the fence and the blade. So this is a good place to be, a good sturdy stance, and you should push your material through from here. I'm going to be exaggerating that stance. I might be a little further out of the way. Hopefully you'll get a good shot of what's going on here. So we talked about wanting to make a rip cut down the center of this 2x4. So the first thing we need to do is to measure it. I've got 3 3/8. So down the middle would be about 1 inch and 11/16. So I need to access my blade to make my measurement. I'll bring my fence in to about 1 inch and 11/16. I'll go ahead and lock that in. So we're set up for our cut. Blade guard comes down. At this point, we need to talk about the height of the blade. So the thickness of this material, being a 2x4, is actually 1.5 inches thick. So the blade at this moment right now is set much higher than my 1.5 inches. Most people drop this blade to where there's very few teeth exposed on the top. That's another safety measure you can do. You don't need all of this extra blade exposed, only enough to cut through the material. So I'll go ahead and lower that blade to a height that is taller than the material, but not so tall that too many teeth are sticking out. Kind of like your circular saw, we're looking at about maybe 1/4 inch to 3/8 exposed blade. So at this point, we're ready to make our cut. Remember, we're going to plug our saw in, and always we'll have the safety glasses. At this point, I'm going to turn the saw on and we'll get this rip cut done. So that's all there is to it. If you noticed my hands and what they were doing, I'm using my hands until the end of that board gets to the beginning of this table. At that point, I'm reaching for my push stick, which has to be very convenient. And this hand is pushing into the fence until I pull out my push stick. At the point that I have my push stick, I abandon my hands anywhere near this saw. Your hands should never come any closer to that saw than the edge of this table. At that point, I'm pushing through, and once again, all the way through with the material. If it falls off the end, that's fine. It will just land on the ground. You can have a bucket there, or if the material is long enough, you can have somebody to catch it on the back side of this table saw. So let's do one more cut. I have a 2x6 here. Let's take 2 inches off of this 2x6. We'll do another rip cut. So I need to set my fence, reset my fence at 2 inches, lock it in. It's not going to move. The height of my blade is good because I'm cutting 2x material, which is the same height as the previous piece. I'll lower my blade guard. My push stick goes right there where I can get to it, very convenient. My saw gets plugged in. And now we're ready to go. So if you notice, this particular length of wood my scrap piece is still attached or placed on the table. I didn't worry about it as I was pushing the material through. If there's going to be kickback on this saw, typically the piece that's in between the fence and the blade is the one we have to worry about. That's why I'm standing to this side and why I'm not so concerned about this scrap piece here. This one I can remove once the saw stopped, and I'm really not concerned about that one, but I do want to make sure that that other piece gets pushed all the way through, doesn't come in contact with the blade, and doesn't get kicked back to me or into my body. Let's talk about a cross cut on this table saw. It's possible to do, not my favorite choice. I would much rather use a compound miter saw for that particular cut. This saw will do it in a pinch though. So we will take the end off of this particular piece of wood, and we want a square cut on this end. So there's a piece of equipment for this table saw we call a miter gauge. And this gauge is adjustable. It can set for different angles, and you're going to run a piece through, and you're always making a crosscut. Typically your crosscuts will be the short width of the wood or across the grain. First things first, we need to set this miter gauge at a 90-degree angle to the blade. We'll do this using a speed square, similar to how we trued the blade for rip cuts. We'll put the speed square up against the blade, and now I need to make sure that my angle or my line up against my miter saw is nice and tight. This means that it's perpendicular or 90 degrees to the blade. I'll turn this knob and lock it down. And now as I was to push it forward, any material that goes into the blade will be cut and it will square off that material. So at this point, we cannot use the fence when we do any kind of cross cuts. If the material, when you're doing a cross cut, touches the fence or comes in contact with the fence, you can get that binding and that kickback that we talked about. It can send that piece flying. So this fence has to come off. Let's take 2 inches off this board and make this cross cut. So there you have it. We made some simple rip cuts with this tool, and we actually even made a cross cut with it as well. A couple things to mention. One is the height that you see me in the classroom with this table saw. And if you think about this tool and how it's always trying to throw material back at you, this high of a position of this tool would be a really bad idea. The closer it is to your face, the more chances you're going to have something, whether that's splinters, sawdust, or even boards thrown into your face. So keep in mind, in the shop we had it much lower, and that's a much better situation. Also, you don't want it too low. You might see people using this tool as it sits on the ground. Now you're in a position where you're pushing material into a saw that you might fall into it. You don't want to fall on a table saw. Even a blade guard might not be able to save you from injury in that case. Hopefully by now you've learned some about the way this all works, how to stay safe with it, its parts and features. When we go to the next lesson, we're going to get into bevel cuts. That's going to put this blade at an angle, and we're going to do some rip cuts, maybe even a cross cut with that blade at that angle. So I'll see you in the next lesson. This video is a production of Trade Skills U, all rights reserved. If you provide instruction in the construction trades and have a need for videos like these, please contact us at tradeskillsu.com.